Let's take another one of the decade resistor test boxes. However, this one I guess is a little bit older. This is from Goerz in Austria. And look at the specifications. Plus minus 0.05%. Wow, look at that. And it even says you can use this to 10 kilohertz. Okay, it also says the highest resistance range you can only go to, what is that, 1 kilohertz, right? So this one is from 1969, by the way, and we got only 3 decades, 10 ohms, 100 ohms, and 1 kilo ohm. And if I have them all in 0, and again I'm going for a 4-point measurement mode. Look at this. This is about 1 kilo ohm, but hear this. See? I was hitting the box on the side, now I'm hitting it again. And the other side. Lifting it up a little bit. See what happens? So it is, there's something inside. There is affected a mechanical problem, and it is not just dialing around here. So now I'm trying to dial the 10 ohm. See? Ooh, look at that. So 10 ohm, 20, 30. I mean, the resistor steps is just incredible accurate. Look at that. Isn't that just crazy? That means if I hit the nulling and then go 10 ohm, 20 ohm, isn't that just amazing? So the resistors in here is crazy accurate, and this is 100. Okay, let's take the 1K. I mean, it really is that accurate. And this is why I think it is interesting to open it and see what is inside, and maybe we can repair this this problem. It is actually just 4 finger screws, and as far as I can see, all we do here is just pick up the entire. Nope, that is not the case. Got some serial numbers. So they locked the switches for 10 steps, but the scale goes to 15. That is actually a little bit interesting. So maybe they're using these scales or those knobs for something else. And also, by looking at the screws here, I mean, the switches are quite big. Also, I'm a little bit, what is that? We got a banana plug here and another one here. And if I look at this, so what is the idea? This is connected to that one, and then what is it? Why is it like that? I think it is. What do I need to do? Maybe it's just those. Then I will be able to pick it all. Oop! Oh, are they loose? Okay, so I put them in. Oh, that's too late. Oh, that was maybe not so smart. Hey. Okay, so they can just be lifted up. Is it like that? Wow. So it is this multi-blade kind of, how do I show this? Yep. This is what it is. We got several different contact blades. This is very, very good for high currents. And this is easy to clean. Okay, great, I can do that. I think I'm going to take those 4 screws out with the red markings. That is maybe, yeah. And see what I said? This is from 1969, definitely. Now we're inside, and I must say I am very, very impressed about the build quality. Wow, have you ever seen anything as well done as this one? Holy. Oh, look at that. That is not good. So something happened in here. I don't know exactly what. But it looks like there's some shiny metal pieces down there. So this resistor was replaced. See, it is not glued to the top here anymore. So all those resistors, they are contacted, okay, at the bottom, but those are at each ends. Aha! Oh yeah, I know why. Look at that. And this is also what it said on the outside of the box. Remember the 1 kilo ohm resistors? That was the only 1 kilohertz range, right? But all the other resistor ranges, that was 10 kilohertz range. Now you know why. So the resistor starts at the end, then the wire goes all the way up, and then it goes all the way back again. And this is why there's no inductance in those resistors. Even they are wire wound, but they are made with low inductance or something like that. Don't you think that is exactly how they do it, so they go up and back again? I need to take a microscope and have a little bit closer look at this, and then I will get back. But look at the wiring and the way they're contacting down to each of the contacts. So that will be the contact plate that is taken up here and twisted like this for absolutely lowest possible resistance. So why don't I see a very stable low resistance? That is probably because of the center thing here. Oh yes, this can bend. So how is this connected to something that is rotating in the middle? I think I'm going to connect my ohm meter and then test. But this is amazing build quality. I guess this was very, very expensive back in the old days. Look at this big solid piece of copper. Oh, you can't help it being a little bit impressed by this. And some isolation here as well. Wow. Okay, I found the problem. But first, let me show you. I was right about the way the resistors there wound. I think it's easier to show on the lowest resistor value. So this is 0.1 ohm. No, it is 10 ohm, right? Isn't that right? Yeah, okay. So this will be 10 ohm. So that will be the 2 endpoints of the wires. And see, it goes up here. And if you look carefully, you see the 2 and 2 wires. This is how they're wired around this. And see at the end, it just goes up. I think it's probably easier. Here in the middle, you can see it's shown a little bit easier, right? So it just goes up here and then back again. So this is indeed very low inductance in a wire wound resistor. Very, very neat design. And this is of course difficult to make if the wire is very, very thin and you need a very, very long wire here. You can imagine they need it to be double as long. So this will be 1 kilo ohm. So this resistor here did indeed blow up, and they replaced the wires. There's actually a little bit evidence. It is different quality windings and different quality or different color as well. So in this setting they gave it too much power, and it definitely blew up big time. And the guy who was replacing this resistor didn't solder. This is the connection from the previous. See? I don't know if I can show you guys this. Let me try and. Here you can see. They didn't solder it. So by fixing this, I should have a very, very good and accurate performance again, I guess. I mean, I can't remember I've seen a decade resistor made this well. This would have been very, very expensive. I don't know what that is. Is that some sort of a glue or what? But wow. Can you imagine trimming these to 0.05%? And what is the temperature constant? Oh, wow. I'm sure my Metcal can easily solder this, because this is what Metcals they can do. So after soldering this bad connection, I have now a completely stable connection between all the different switches. I have also cleaned all the contacts. Now you can see how nice and shiny they are. And this is the contact. You see this is made for very, very high currents, or at least very, very low resistance. So every time one of my switches is in 0, I get this 46. Amazing, so it's completely repeatable. Let's try and hit the null, and then 10 ohms, 20. Ooh, now we're talking some serious performance. Oh my goodness. So this is the 100. Wow, manna. What do you think you need to pay? You want to get one of these today with every resistor hand wound and handmade and special low inductance resistors and all sorts of stuff. So this is 10K, and let's put them all to max, and then the last one again to max. Yes, exactly. Wow, I am very, very happy about this now.